message it's about to bring, it sure came to Earth quietly. Just a tiny chirp of a sound from a billion light years away. But for giddy scientists, it spoke volumes. After decades searching, finally, gravitational waves. And if you're wondering what that means for you, consider this. Till now, we've been deaf to the sounds of the universe. Today, suddenly, we can hear. You can bet that's got Bob McDonald all excited, and he can't wait to tell us why. But first, the CBC's Stephen D'Souza explains today's big announcement.
Einstein, it turns out, was right, even if it took 100 years to prove it.
Ladies and gentlemen, we have detected gravitational waves. We did it.
Scientists here compare the discovery to Galileo aiming the first telescope at the stars 400 years ago.
It's the first time the universe has spoken to us through gravitational waves. And this is remarkable.
Einstein described gravity as the fabric of space-time. He predicted that the collision of two massive objects would cause gravitational waves that would spread like ripples in a pond across the universe. But proving they exist was incredibly difficult. Scientists around the world, including at the University of Toronto, had been searching for decades. The signal finally came when scientists least expected it. Their laser detectors had just finished a 5-year upgrade and were still in testing mode when they heard this.
Whoop. That's the chirp we've been looking for. This is the signal we have measured.
That sound is waves of energy sent out when two black holes collided, an event that happened 1.3 billion years ago, only now reaching Earth.
There's a whole new window on the universe. We can see things we couldn't see before.
At this Canadian lab, Neil Turok and his team are working to advance Einstein's theories. Till now, scientists have relied on things like radio and light waves to study the universe. Gravitational waves are much different. They're expected to reveal huge surprises about many mysteries, including black holes and even the origin of the cosmos.
Literally, using gravitational waves, we can look right back to the beginning of the universe, just see what happened. Developments like these, I believe, tell us something about who we are. They tell us we have the capability to understand the universe at such a basic level.
Scientists are already working on the next generation of gravitational wave detectors that will be placed tens of millions of kilometers from Earth, listening deep into space. And Peter, scientists can't wait to hear what may be discovered when they tune in.
All right, Stephen, thank you. Well, when earth-shaking science news hits, you know where we turn. Bob McDonald is here to walk us through it all. First of all, Bob, gravitational waves, tell us more.
Well, they're kind of counterintuitive, Peter, and it all goes back to the way Einstein saw gravity. He didn't see it as a simple pull like the Earth pulling down on an apple that falls out of a tree the way Newton did. He saw it as space itself curving. So I have a model of Einstein's universe here, a salad bowl and a t-shirt, and when space is empty, it's flat. But if you put something really massive in it, like a star, say our sun, it makes an indentation. It makes a gravity well. And actually the Earth and all the other planets are rolling around on this gravity well. That's why we're falling towards it. We're going downhill. Well, if you have two objects, not just one star, but two or two black holes, they make a really deep gravity well. And if they're spinning around each other really, really fast, and then eventually they hit and they form a new black hole, a bigger one, they cause a lot of ripples here. They make this surface vibrate. And it's those vibrations of space and time that ripple out across the universe and that we see here on Earth. What's different about this, Peter, is that it's not like a light beam going through space. It's space itself shuddering, sort of like an earthquake. The whole medium is shuddering, and Einstein himself predicted them. He said we probably will never see them, but now that we know the reality, he was right. He'd be very happy today.
Listen, it's fascinating, but why is it important?
Well, I think of it as getting another set of senses. Imagine going through your entire life and all you have is your eyes, your vision. Now, you'd see the world and you'd learn a lot about the world, but then all of a sudden you got hearing. And you'd see the same world in a very different way. You'd suddenly find out about the wind in the trees, birds singing, traffic noise, everything. So you just expand your knowledge. Gravity waves, gravitational waves, and gravitational astronomy can let us look at the same universe now in a completely different way. We can see black holes doing things, which is what they announced today. We can see the Big Bang itself. So it's just another medium that lets us see the universe, and who knows what we're going to see with brand new senses that we've never had before.
Not sure I've ever seen you this excited before.
It's a big day, Peter. This is historic.
All right. Thanks, Bob. Bob McDonald's in Victoria tonight.